Hello students, my name is Harish and today I'm going to explain on the topic electric motor. This topic is from the chapter magnetic effects of electric current. So let us start. What exactly is an electric motor? An electric motor is a device which converts electrical energy into mechanical energy. Okay. Now what is the principle this electric motor works on? Now when a rectangle coil carrying current is placed in a magnetic field, a torque acts on the coil which rotates it continuously. Okay, and when the coil rotates, the shaft attached to it also rotates, and thus it is able to do mechanical work. So if you look at this diagram, this is what an electric motor diagram looks like. So what they're trying to say is that when this coil continuously moves, it will rotate this shaft, and this coil will move with the help of electrical energy. So basically, we are converting this electrical energy into mechanical energy. Okay. So if you read the principle line again, a rectangular coil carrying current is placed in a magnetic field. A torque acts on the coil, which rotates it continuously. And the coil rotates, the shaft attached to it also rotates, and thus it is able to do mechanical work. Now, what are the parts of the electrical motor? The automobile consists of, first of all, insulated copper wire, magnet poles, split rings, axle, brushes, and source battery. So, if you look at this figure, you can say this is ABCD is insulated copper wire. Then you have your magnetic poles, you have your brushes, you have this split ring, and you have your axle. This is what makes up an electric motor. Now, how does this motor work exactly? So the coil is powered, a magnetic field is generated around the armature. Okay, the rest of the armature is pushed away from the left magnet and drawn towards the right, causing rotation. Now we all know that when an electric carrying conductor is kept in a magnetic field, it will experience a force, right? So basically, if you notice in this, what they're trying to say is that if you pass electric current through this coil, okay, if pass electric current this coil, a force, this electric coil will experience a force due to the magnetic field present around it, and this magnetic field will rotate it in a circular motion. Okay, and that is what will move the axle. To understand exactly how this phenomena works, let us read the next one. Now, when the coil turns 90 degrees, the brush loses contact with the commutator. Okay, and the current stops flowing through the coil. In this case, commutator is a split ring. Okay, and however, the coil keeps turning because of its own momentum. And now, when the coil turns to 180 degrees, the sides get interchanged. Okay, so as a result, the commutator ring P is now in contact with brush Y, and the commutator ring Q is in contact with brush X. And therefore the current continues to flow in the same direction and the rotation keeps on going. So basically, if you notice at this electric generator, at first P is with X and Q is with Y. Okay. So now as current passes through it and due to this magnetic field, this AB will experience a force, right? And it will try to rotate it like this. And once it is half rotated, then this Y will now be in contact with P and this Q will now be in contact with X. So in that case, the direction of the current is reversed. Instead of going like this, it will go like this. And once you start flowing like this, then again, due to the electric magnetic field, it will rotate the other half. Okay, so basically, a complete rotation of this axle will take place because of the complete rotation of this coil. And this keeps on going until there is current inside that coil. And that is how we convert the electrical energy into mechanical energy. Okay. And the next point comes is that how to increase the efficiency of this DC motor. Right. You can increase the efficiency of a DC motor first of all by increasing the number of turns in the coil. As we all learned that if the number of coil is increased, then the total force will also increase. Right. Next, we can also increase the strength of the current, right? Higher the strength of current, more is the magnetic field. Then we can increase the area of cross section of the coil. We can increase the area. Next, we can also increase the strength of the radial magnetic field. Okay, so if you follow these 4 points, you can increase the efficiency of the DC motor. Thank you.